Hello, and this time we're looking at level 0, so the easiest questions about complex impedances. And really the only thing you need to know about complex impedances for this is that complex impedance of a capacitor, ZC, 1 over j omega c, complex impedance of an inductor, ZL, j omega L, and the complex impedance of a resistor, ZR, is just R, the resistance. Only thing that might trip you up is that omega here is an angular frequency, so omega is 2 pi times f, where f is the frequency in hertz. Right, let's have a go at some problems. First one, magnitude of the impedance. Note that it asks for the magnitude, not the complex impedance. So all we need here is the omega L one. So 2 times pi, you can just write pi for pi, 2 kilohertz, 2k, times, in this case 10, since this inductor is 10 henries. Done. Even easier, it's a resistor, so the complex impedance will be equal to the magnitude of the impedance, since it is real, and that is equal to the resistance, which is 300. A capacitor, again it's asking for the magnitude, so we don't have to worry about the phase angle, we can ignore the j term, and this would be just 1 divided by 2 times pi times the frequency, 500 kilohertz, times the capacitance, 3.3 picofarads. Fine. Complex impedance, that would be j times 2 times pi times 10k times 4m7. That's j times 2 pi 10k is omega, and L, the inductance, is 4.7 millihenries. So that'll get us that one. And only one we haven't tried is the complex impedance of a capacitor. And we can do that one. That is 1 over 2 times pi times 50 kilohertz times 6p8 times, not forgetting the j, 1 over j omega c. That's the omega, that's the c, and that's the j. Right, that's about as hard as it gets at level 0. Pretty straightforward, really.